Let's take a look at this buoyancy problem from 2009 here. So it says 3 objects of identical mass. So that's probably going to be important. So identical mass attached to strings are suspended in a large tank of liquid as shown above. Must all 3 strings have the same tension? Yes or no? And then justify your answer. Well, let's think about one of these. Let's focus in here on A. So if I draw a free body diagram, I've got tension up here, and they're immersed in a liquid, so we'll have a buoyant force up, and then we'll also have the force of gravity down. Now, how did I know to draw the force of gravity bigger than either of these? Well, these two together must equal the force of gravity. So if we set this up here, we can say tension plus the buoyant force minus the force of gravity equals 0. Well, let's solve for the tension here. We'll move these to the other side. So tension is equal to the force of gravity minus the buoyant force. They all have the same mass, so they all have the same weight. But must they all have the same buoyant force? Well, buoyant force is equal to the density of the fluid they're in times the volume of the fluid they displace times gravity. Well, they're all in the same fluid, and they all experience the same gravity, but there's nothing that says they have to be the same volume. They could be made of different materials with different densities. So they don't necessarily have the same volume, so they don't necessarily have the same buoyant force, so they don't necessarily have the same tension there. Let's look at the next part there. So it says object A has a volume of 1 times 10 to the negative 5th cubic meters and a density of 1,300 kilograms per cubic meter. The tension in the string to which object A is attached is 0.0098 newtons. Calculate the buoyant force on there. Well, I'm going to use this same basic setup that I had here. I'm just going to write it for buoyant force instead of for tension there. So if I keep that, the buoyant force will equal the force of gravity minus the tension there. So now let's start to plug in for some of these values. The buoyant force will equal, the force of gravity will be the mass of the object times gravity, and they gave us the tension. So I'm just going to wait till I get everything else to plug in for that just to save some space. They didn't give us the mass, and so some people get stuck there, but don't forget the most important substitution of this unit. Mass is also density times volume. So we do have the density and we do have the volume there. So now we can plug in for each of these values here. So the buoyant force will equal the density, which is 1,300 kilograms per cubic meter, times the volume, which is 1 times 10 to the negative 5th cubic meters, times gravity of 10 meters per second squared, minus the tension of 0.0098 newtons. And if you do all of that, you should get that all of this works out to be 0.13 newtons, and we're going to subtract out the 0.0098 newtons, and that leaves us in the end with a force of, I miswrote here. This is not the force of gravity. This is the buoyant force. That's the force of gravity right there. So the buoyant force here is equal to about 0.1202. We could just round it off to 0.12 newtons there. Next, it says calculate the density of the liquid. So let's look at that. How are we going to get the density of the liquid? Well, we know that the buoyant force is also equal to the density of the fluid, the liquid, times the volume displaced, times gravity. So if we rearrange that, then we get that the density is equal to the buoyant force over the volume over gravity. Well, we just solved for the buoyant force, so we have that. The buoyant force is 0.12 newtons just about. And the volume of the liquid displaced is the same as the volume of the object since it's completely submerged. So that will be 1 times 10 to the negative 5th, and then gravity is 10. And so when we work all of that out, we get 1,200 kilograms per cubic meter. So something denser than water there, because water is 1,000 kilograms per cubic meter. All right, last question here. It says some of the liquid is now drained from the tank until only half of the volume of object A is submerged. Would the tension in the string to which object A is attached increase, decrease, or remain the same? Justify your answer. So imagine now what is happening is we drain the water until it's like right here. So only half of A is submerged. Well, remember when we go to write all of this out here, some points. If less of it's submerged, then it displaces less water. So it displaces less, or less liquid here, because it's not water. So it displaces less liquid. That means that there is less buoyant force. And if there's less buoyant force, then there must be more tension, because the tension is going to pick up whatever remains to balance it all out. So the tension will increase because the buoyant force is decreasing.